For this is that this is the reason why you want to think about ice baths or these sorts of things. And most people, won't do this, but at the very least understand that our bodies are sort of made for some temperature differences. And when you put yourself into an ice bath, and this is what the pro players do, what happens is your body starts to heat up. So you don't want to freeze, so your body will rev up. And when you rev up, you're actually increasing the temperature inside of you. You increase the temperature of the water around the mitochondria. The mitochondria has these sort of respiratory proteins, and they're a certain space. When it heats up, they shrink together and they work more efficiently. Just like your iPhone, when it gets cooler, it works better. So this whole idea of maybe a little bit of cold part of your shower or other things, I mean, it doesn't sound attractive, but just know our bodies are kind of made like that. And so this is probably one of the things I definitely need a lot of help on, is finding a good spring water around here. There are ways to get good water. Our tap water is probably less than optimal because of all of the, frankly, medicines that are inside of it, because we have a lot of like antibiotics and even antidepressants and all these things in our water supply. The fluoride is in there. It's actually pretty harsh. So it is good to try to get water that, as much as you can, is something like a spring water that doesn't have pollutants in it, as well as you'd like it where it's non-fluorinated. So these are things, if someone has a good water supply, I basically get that Pellegrino type water, which is from Italy, those sorts of things. We actually one time had a fun little thing where my daughter wanted to have a certain kind of water, and I said, you can't tell the difference. And so we actually had a water taste test. I highly recommend you do this. So you get like Sparklets and Arrowhead and Perry House, and you just make them like you're doing a wine tasting, and they have little things to figure out what it is. And I grew up in the days where we drank out of a hose, so we had hose water, and they thought the most expensive one was the hose water. So it's just a lot of fun. But I do think it's worth the time to try to come up with a good water supply. As I said, we have a filter at our house so that gets rid of most of the things. I can't tell you exactly if it gets rid of everything. Some people like reverse osmosis type things, but this is definitely a fertile area to improve your. First, you want to increase the volume of water, and after that, if you can get a better water content, I think that would be very healthy. So now I want to just finish up with one of the most amazing guys, which is Gerald Pollack. So he is a guy who is the one that sort of came up with this idea that water is like a battery because it has another phase that we never heard of. We've all heard about, liquid, solid, and gas phase, but there is a fourth phase that's gel-like.
Water, cells, and life. That covers a lot of ground. But I want to be more specific. I want to talk about, where do we get our energy? Now, obviously, we get a lot of energy from food, but I'm going to introduce the idea that we might get additional energy from light. Now, why do I raise this question? Well, I raise the question because nature commonly uses light to supply energy. For example, green algae. They photosynthesize. They take in light, and the light creates energy. And the same is true of some bacteria. They also photosynthesize. But what we know best, of course, is green plants. So green plants soak up light and convert that light into chemical energy. And that chemical energy then drives whatever the plant does, metabolism, growth, bending, you name it. And all of this works through water. The roots of the plant absorb water, and that water goes to the leaves. And what happens in the leaves is that when they receive light, they take the water that's inside them and split the water into positive and negative, H plus, OH minus. This is the first step of photosynthesis, and it's driven by light. So light, you might say light creates this kind of battery with plus and minus. And the question is, are we also solar powered? Do we use light to get some of our energy? And I'll show you that we actually do. the agent, the first step of photosynthesis, that is the splitting of water into the negative and positive. Mother Nature, when she created us, hasn't forsaken this wonderful mechanism of using light to get energy. And I'll show you also that leads to many insights in terms of our own health. Everybody knows that our body is mostly water. And in our laboratory at the University of Washington, we're studying water, and we came upon something really interesting. When water meets certain materials, these are hydrophilic or water-loving materials, which means that if you have a surface and you drop the water, it spreads out instead of beating up the way it does, for example, on Teflon. So what happens is that the water molecules split into the positive and negative, and the negative ones line up, as you see here, next to the hydrophilic material. This is actually negatively charged water is in fact a different phase of water. It's not even H2O, it's actually H3O2 is what we found. And we refer to this fourth phase, if you will, of water that is beyond solid, liquid, and vapor. This fourth phase is semi-crystalline water as EZ. So what's EZ? EZ stands for exclusion zone. And the reason we called it exclusion zone when we found it is as this phase of water builds, it pushes out everything that's inside of the water, that is solutes, particles, whatever. And so we called it logically exclusion zone, and EZ is, well, easy to remember. So essentially this is potential energy because it's just like a battery of water. And all batteries, of course, need to get charged, and the question is, well, where does the energy come from to charge this battery? Your cell phone needs to get charged, it's a battery, and this is another battery. And the answer came from a student who was doing something that he was not supposed to do. So he was carrying out an experiment, and this experiment is using some hydrophilic material and putting water next to it, just as I've shown you. He took a lamp. The lamp was sitting right next to the experimental chamber, just for fun. He shined the lamp on the chamber, and what he saw was really astonishing. He noticed that because of the illumination, the exclusion zone, the EZ, expands. And it expanded hugely, and when he took the lamp away, it came back to its original shape, which is a thin band of EZ. You see at the upper left running parallel to the surface. So, well, it didn't take a rocket scientist to figure out that if you shine light, it gets bigger, and maybe the light is what's responsible, the photons are responsible for providing the energy to grow this exclusion zone. So obviously we were really impressed by this student's result, and we began to study different wavelengths of light, ranging from the ultraviolet through the visible light, through the infrared light, and we found that by far the most effective light was infrared. Infrared is actually all over. It's hard to get rid of, and it's not just inside, it's outside too. And this is literally free energy. We learned about free energy in our chemistry textbooks, but this is literally free. It doesn't cost you a nickel. It's there. And because it's there all the time, it means that when you have water next to a hydrophilic material, you always have EZ water. And of course, if you add more light, then the EZ grows. You see, so light is basically feeding the growth. And so this feature, this light-induced separation of charge, can also be used to get electrical energy from light and water. All you need to do, at least in theory, is stick two electrodes in, one in the negative, one in the positive, and you ought to be able to get electricity to light a light bulb. We've demonstrated that this is actually the case. You can see here, you flip the switch, and you get the light. So just as water behaves as a light-driven battery, cells actually operate much the same way, also as a light-driven battery. That's something you perhaps never thought of. But think about the cell and what's inside. So inside the cell, you've got large macromolecules.
So think of these as mitochondria.
And these proteins have hydrophilic surfaces. And of course, there's water, lots of water inside the cell. And so what happens is that there are exclusion zones. You have EZ water, which has a negative charge. And the positive charges would be lying beyond those negative charges. So the reality is the cell is really crowded with proteins mostly, and this negative EZ practically fills the cell. And what happens is that the positive charges are pushed out, and the cell is negative. But negative charges near each other, they repel. They want to get away from one another. And that tendency to repel constitutes potential energy. And this potential energy is basically released in the form of protein folding. That is, the proteins ordinarily occupy one configuration, but they fold. They start this way and they fold into another configuration. So, for example, if this were a muscle cell, the proteins would be in one configuration, and they move to another configuration, and that's what is responsible for your muscle cells contracting, and it allows you to jump. So the way it works, it looks like this on the left side. Here is a typical protein in its extended form, and it's got easy water around it. And what happens is the easy water melts into ordinary water, and the protein is able to fold. But of course, it's got to go back to the original position. And what happens is it does as easy water builds around it. So this is the normal function of a typical protein. And on the right side, imagine what happens with no EZ. See, with no EZ, it doesn't have the potential to get back to its original configuration. And so it's not working. So your muscle, or whatever cell, is not working properly if it doesn't have EZ water. Of course, if you have some EZ water, then it functions, but not quite as well as if you have a full complement of EZ water. You have potential energy from the EZ, which drives the work of the cell. Light, as I said, is responsible for building the EZ and building negative charge, and that's what gives the cell its energy. And then the energy is consumed as these proteins do the work of the cell, your work, and fold. And if you just connect the dots between the two, so light is actually driving the work of your cells, or light is actually driving your function. Well, also inside the cell are structures called mitochondria.